And let's look at a few examples. So example 8, a particle moves in a straight line with velocity function given to us here. T squared subtract 3t plus 2. Answer the following without using a calculator, so non-calculator question. How far does p travel in the first 4 seconds of motion? So how far? That means total distance. Okay, so in this case we're looking at total distance in part A. And part B, find the displacement of p after 4 seconds. So how far means total distance. All right, so with displacement, part B, we're just going to have to calculate the position at 4 seconds and then the position at 0 seconds, and then subtract those. For part A, though, we need to follow all of these steps 1 to 5. Okay, so I've written them down here, each step. Step 1 was draw a sign diagram of the velocity function so we can determine the times at which the object changes direction. So to draw a sign diagram, remember we need to determine the zeros. So this guy's factorable. T subtract 2, t subtract 1. So the zeros occur at 1 and 2. So the sign diagram, starting at 0, 1, 2. This is a quadratic. It opens up, so positive, negative, positive. And remember, if you're not sure about that, try a number in between 0 and 1 and see whether it's positive or negative. Try a number in between 1 or 2, see if it's positive or negative. Try a number bigger than 2 in the function, see if it's positive or negative. Step 2, determine s of t by integration and include the constant of integration. Okay, so integration of this with respect to t, because that's the variable we're using. T, increase the exponent and divide. Increase the exponent and divide, increase the exponent, and plus c. Okay, now we need to figure out what is c. So do we know what c is? Sometimes we will, sometimes we won't. So do we know what c is? We do not have any points given to us, any actual points on that function, so no, we can't figure out what c is. Going to have to keep it. Step 3, calculate s of t1, s of t2, and s of any places where it changes direction. So s of t1, because the question asks us from in the first 4 seconds, that means that t1 is 0 and t2 is 4. All right, and the other places we need to find are when t is 1 and when t is 2. So we're going to have to calculate all 4 of those. So s of 0, substituting that in. Here's our function we're talking about. So 0, substitute 0 in here, substitute 0, substitute 0, and plus c. So this equals c. S of 0 equals c. S of 1. One-third, subtract 3 over 2, plus 2 plus c. Common denominator of 6, so 2 over 6 minus 9 over 2 plus 9 over 6 plus 12 over 6 plus c, which is 5 over 6 plus c. So s of 1 equals 5 over 6 plus c. And s of 2 is 2 cubed over 3, subtract 2 squared over 2 plus 2 times 2 plus c. 8 over 3, subtract 12 over 2 plus 4 plus c. 12 over 2 is 6. So 8 over 3 subtract 2, which is 6 over 3. So 2 over 3 plus c is s of 2. And we need s of 4. 4 cubed over 3, subtract 3 times 4 squared over 2 plus 2 times 4 plus c. This is 64 over 3 minus 48 over 2 plus 8 plus c. That's negative 24. So subtract 16, which is 48 over 3. So 48, 16 over 3 plus c is s of 4. All right, we have these 4 values. Step 4, draw a motion diagram. All right, so motion diagram, we need to determine which of these values is bigger and smaller than the others. So c is the smallest, so it will come first. So this is the motion diagram. There's just talking about how far away we are. The next biggest is 2 over 3 plus c. The next biggest is 5 over 6 plus c, and then way over there would be 16 over 3 plus c. All right, so which place occurs before the others though? So according to time, where are we? So at 0 time, we're at c, so we're starting here. At time 1, we're at 5/6, so we go all the way over to here in 1 second. At time 2, we're at 2/3, so that means we change direction and we're back here at 2/3. Then for s of 4, we're at 16/3, so then we change direction again and go this way. All right, and that's our end point. Now, does this make sense? In other words, from our sign diagram up here, we were supposed to change directions at t equals 1 and t equals 2. So did that happen? Change direction at 1 second, change direction at 2 seconds. Yes, that did happen. Okay, so perfect. And our starting point is 0 seconds. Our end point is 4 seconds. All right, so we can calculate this distance now. We have to calculate from here to here. So that is 5/6 plus c subtract c, which is 5/6. Then we have to calculate this portion, which is 5/6 plus c subtract 2/3 plus c, which is 5/6 plus c, subtract 2/3, subtract c. Okay, so those cancel. So that's 5 over 6 plus, nope, subtract 5 over 6, subtract 4 over 6, which is 2 over 6, which is 1/3. Okay, and this last portion here, which is 16 over 3 plus c, subtract 2 over 3 plus c, which is 16 over 3, subtract 2 over 3, which is 14 over 3. All right, and those 3 places added together, 14 over 3 plus 1 over 3 plus 5 over 6, those 3 parts of the trip added together, then are 28 over 6 plus 2 over 6 plus 5 over 6, 35 over 6. or 5 and 5/6. And our units is meters. Why in the book do we have 5 and 2/3? Okay, I had a little error here. I found it. It is right here. 5/6 subtract 4/6 is 1/6. Okay, so this is 1/6. 1/6. 34/6, which is 5 and 4/6 or 5 and 2/3. Okay, that's the correct answer. And our units is meters. Whew. All right, so we've finished now part A. Part B is simply find the displacement. So we want to do S of T2 subtract S of T1. And again, we can get this from our motion diagram. We can see that T2 was at 4 seconds. Okay, so S of 4 minus S of 0. So that was 16/3 plus C minus C. So 16/3 or 5 1/3 meters. Okay, so total distance traveled could be different than displacement.